Advanced Math, Lesson 97, the ambiguous case. So where the ambiguous case comes from is when we're given data about a triangle, but we don't have the triangle, and we have to try to draw the triangle. So the ambiguous case pretty much means that based on the data given, multiple versions are possible for this triangle. And we'll go more of that in a second. The main thing I want to focus on is how they're going to be using the nomenclature in these triangles. So when you get ambiguous case problems, the angle will always be opposite the side of the same letter. So in ambiguous case problems, the angles will be capital letters A, B, and C, and the sides will be lowercase letters, and those sides will always be lowercase opposite of the letter that the angle that they have. So uppercase A, the angle A, will be opposite the side of lowercase a. Angle B will be opposite the side of B. Angle C will be opposite the side of C. Something you may have noticed from our law of sines and cosines problems, but if you didn't, that's fine. And then it's just something that we have to do every time we draw these, because that's what the book is using. Sometimes they'll tell you, A is the opposite side, but our particular book is going to set them up like this every time, where the lowercase letter is always the side opposite that angle. Now that we've got that baseline information out of the way, let's talk more about this ambiguous case. Excuse me. First example, they tell us A is equal to 40 degrees, side A is equal to 4, and side C is equal to 9. They want us to draw the triangle and solve for the other sides. So we have to draw and solve other sides. Now, the first thing we can do is try to figure out what kind of triangle this is. And we're going to use this using our trig identities. So based on this information, we could have a bunch of different options for this triangle. And they look like this. So the first option is it makes a right triangle. Second option is it doesn't make a triangle at all. Third option is make an obtuse triangle. Well, actually, sorry, yeah, the third and fourth options are kind of like the same result. So this is where they call it the ambiguous case. So depending on what we see from this trig identity, we could have two possible triangles, and they could both look like this, where A is the same length. One has it slanted in, the other one has it slanted out. The last option gives us an obtuse triangle, and there's only one possibility for A because A is bigger than 9. So the way that this looks on paper for these different options, I wrote these out of order. That's okay. Yeah. So the first option is that if A, or if your opposite side, is less than the height of the triangle, then you don't have a triangle at all. If A is equal to the height, then we have a right triangle, right? So that's where the trig identity would work in. If A is greater than the height and it is less than B, or it should say C. Whoops. And it is less than C, C being the C being the other side that you're given. Then there's two possible triangles. Those are the ones we were looking at in figure 3 and 4. So these two possible triangles. Oops. All right, and so these two possibilities come with whether or not side A slants to the left or to the right. And then the last one is that if A is bigger than the height and bigger than C, there's one possible triangle, which is what we see in figure 5 there underneath the cord to my camera. So let's start working through this and figure out which one we have. The way we're going to do this is we're going to solve for the height of the triangle. So we'll make a quick sketch of what we have so far, which is we have side C is equal to 9. We have a nondescript side B. Then we have an angle of 40 degrees. So it doesn't matter where this last line is to find the height. I'm just going to have to take 9 times the sine of 40. Excuse me. So I grab my calculator. Oop. Type in 9 times the sine of 40. And I get 5.785. I'm just going to round to 5.79. So I now know the height of this triangle is 5.79. Now, what did they tell me C or A was? Okay, so they told me A was less than the height. So if A is less than the height, Can this be a triangle? No. So this is not a triangle. And that would be our answer. Not a triangle. They tried to trick us, and they wasted our time. Well, we didn't waste our time. We learned something. So that's how this works. We'll go ahead and do one more example, because this can be somewhat daunting or confusing concepts if you're having trouble with the use of the trig identity. Actually, maybe I can explain this a little better. So based on the information they gave us, side A, this is 9, not A. I know, I can already hear half the class now. Mr. Claiborne, your 9s look like A. Okay, so since this is angle A, side A would have to be over here. If this height has to be 5.79, then side A is only 4, which means it's not big enough to make a triangle. All right, we'll do one more. They tell us draw a triangle and find the missing parts if A equals 27 degrees, A equals 5, and B equals 7. Okay, so B would just be the opposite side and would take the place of C. So let's draw what we've got so far. We've got a 27 degree angle A. Side A is going to be opposite here. B is the bottom line. We'll make that 7, so that B equals 7. So then to figure out the height of the triangle, the height would be somewhere along this edge. All right, we would have to take 7 times the sine of 27. So 7 sine 27. I get 3.177. I'll make that 3.18. So the height is equal to 3.18, which is less than A. Great. So over here, if A is greater than the height, so it's not equal, so it is a triangle, but it's not a right triangle. If it's greater than the height, but less than C, or in this case B, we have 2 possible triangles. So we already know that A is less than B, and it is greater than the height, so that gives us 2 possible triangles. That's one triangle where A slants inwards, like so, where it slants inward, and then there's another possibility where A slants outward. So how do we figure out these other pieces? And this is the ambiguous case. How do I figure out the 2 forms of the triangles? Which one do I go with? So many questions. So the way I'm going to solve this is I'm just going to sketch 2 different triangles. I'll go ahead and do one for each case. One where the opposite side slants in and the opposite side slants out. So let's draw this in green. Try to make it as neat as I can. Alright, so let's say the length of 5 slants in. We would have something that looks like this. So this would be 5, this would be 7, this would be 27 degrees. Alright, so that's one of our triangles. And the other one look like this. We got length 7. One's going to be longer. So this one is not to scale, but that's okay. Let's say that's 5, this is 7, and this is 27 degrees. Now, once we've sketched both of our possibilities, we can then use law of sines. Let's fix our focus. Okay, now using law of sines, we just take the opposite sides. So 5 to the sine of 27 is going to equal 7 to the sine of angle B, angle C. And then we can just cross multiply and solve here. So then we're going to get that 7. Once we finish simplifying all this, we'll get 7 times the sine of 27 degrees divided by 5 is going to equal the sine of B. So we'll punch this into our calculator. So 7 times the sine of 27 gives me that. I divide it by 5. I get that, and that's going to be the sine. That's going to be the sine of B, so I have to do negative, or the inverse sine function on that. and we'll do 0.6358. I get about 39.46 degrees. So that is one option. So for B here, I have 39.46 degrees. Now the question is going to be, if I do the exact same math on this triangle, how do I get the other version of angle B? Because it's going to end up being the same equation over here. Well, once we solve one of these to get the other version of B, all we have to do is subtract this from 180. If you'll notice, this little extension that I've drawn here and here, it shows the different halves that this angle will create. And these two versions of B are actually going to be supplementary. All right. So if I subtract this one from 180, then I get the other version of B. So we'll just add a negative 180. That gives me 140.54. So 140.54 degrees, and that's the other version of B. So now that I've got the two different angles, I can continue using law of sines to figure out side C and angle C. I'm not going to go ahead and do that last part, but because this is the real trick here. This is where we run into the ambiguous cases. You've got one equation, but you're supposed to end up with two possible angles. So we have to memorize mostly these four different cases here. If your opposite side is less than the height, it's not a triangle. If it's equal, it's a right triangle. If it's greater than but lower than your adjacent side, there's two possible triangles, and this is the one we have to look out for. If it's greater than both, then there's only one possible triangle, and we won't have to do any of this addition or subtraction of supplementary angles. That's it for this lesson. If you guys have any questions, let me know on the school website, and I'll see you in class.